Hey guys, we're going to look at the properties of limits for this lesson. So we're going to kind of be able to manipulate some things based on these properties because that's what a big part of what calculus is that it's mainly just manipulation of certain expressions and that kind of sort of thing. There's one or two steps of calculus, the rest just algebra, but it's in the form of manipulation. So we're going to look at some properties today for limits. So suppose that the limit as x approaches a of f of x is equal to L, and then the limit as x approaches a of g of x is equal to M. Now, notice that a has to be the same, so they have to be approaching the same number, okay? Then find the following for L and M. So in terms of L and M. So as the limit as x approaches a for f of x plus g of x, then that's the same thing as the limit as x approaches a of f of x plus the limit as x approaches a of g of x. That's a, not 9. And then, so that's going to be equal to L plus M. So whatever the value of L is plus whatever the value of M is, you would just add those two together. Same thing with subtraction. So it'll look the exact same way. So you just take the limit as x approaches a of f of x minus the limit as x approaches a of g of x, and that's equal to L minus N. M, sorry, not N. And then same thing with division. You're just going to divide the two. Okay, so you just divide the two limits, and then whatever those are approaching, you would just end up dividing. So L divided by M. And then same thing again with multiplication. So you get L times N. All right, so now let's look over here. You have some C, which that would be a constant out front of a function. Okay, so like 3x squared. The constant there would be 3, so you can basically, I would say you could say factor that out. Okay, so for this one, this would be the limit as x approaches a for c. Well, if that's a constant, that's just going to be whatever that constant is. That's just going to be c. And then multiply it by the limit as x approaches a of f of x. So just be the constant times L, whatever that limit is ended up there. Okay, same thing when you take the limit of something to a power. It's still going to be that limit, whatever the limit converges to that power. So you end up with L to the p power. And then this we kind of talked about just a while ago, the limit of c, any constant, is just going to be c, okay? So it's just whatever that constant ends up being. So let's look at what this looks like as far as a graph goes. So we have the limit as x approaches 2 from the left of f of x plus g of x. So I need to find the limit as x approaches 2 from the left of f of x. So f of x is that first graph, and so as x approaches 2 from the left, it looks like we are approaching -5. And then same thing for g of x, which would end up being -3 based on this point right here. So then I'll just add those two together, and I would get -8. Okay. Then let's look at I'm just moving across to the right. We have the limit as x approaches -1 of 2 times f of x minus 3 times g of x. So as x approaches -1 of f of x, we have -6. So this piece right here is going to be -12 because it's going to be 2 times that. Now for g of x, we have -1. So this ends up being -3, and I'm going to subtract. So that is going to give me negative 9 because it ends up being negative 12 plus 3. So pay close attention to that negative sign there. As the limit as x approaches negative 3 of f of x minus g of x. So we have, for f of x, you get negative 2. It's still, even though there's a hole there, remember they still converge to both of those there. The limits from the left and the right are there. So that's going to be negative 2. So this piece right here is negative 2 minus, and then for g of x at negative 3. Okay, so what you'll notice here is that as I approach negative 3 from the left, it's positive infinity. And then as I approach negative 3 from the right, it's a negative infinity. So therefore, this one, D and E, this one does not exist. So this limit I can't even find, so it just does not exist. And why is that? Well, because the limit of g of x at negative 3 does not exist because the limit from the left and then the limit from the right are not equal, and they're not a real number. Remember, they have to be a real number. So even if both of them were approaching positive infinity, still wouldn't work. All right, moving down 1 and all the way over. Okay, so as x approaches 6 of negative 2 times f of x divided by g of x, then I'm going to take the limit as x approaches 6 of f of x, multiply it by negative 2. So it looks like it is approaching negative 4 right here. So this is approaching negative 4, or it is equal to negative 4 if I just sub that in. So this is going to be a positive 8 on the top. And then as g of x approaches 6, that is 6. And so I end up reducing that down to a positive 4/3. Now, remember, AP test, you don't have to reduce it down or anything like that. You can leave it as improper, even if they were both negative. If it was negative 8 divided by negative 6, you could still leave that. Okay, so if it's a free response on multiple choice, you would have to reduce it to get the right answer. Okay, so I have 2, the limit as x approaches 4 of 2 times f of x times g of x. So I need to find the limit as x approaches 4 for f of x, which is going to be negative 3. So this piece right here is negative 3. And then the limit as g of x approaches 4, which would be 4. So this piece is positive 4. So I'm going to multiply those two and then multiply it by 2, which would give me a negative 24. So I'm just going to make sure we write this all out, especially for any kind of free response. So the limit as x approaches negative 2 of f of x squared. That's going to be the limit as x approaches negative 2 of f of x, all of this squared. So then the limit as x approaches negative 2 of just f of x, negative 2, is going to be right here at negative 5. So this is going to be negative 5 squared, which is a positive 25. So just writing out those properties here. So the limit as x approaches 2 from the right of the square root of 2 times g of x. So we didn't really talk about this, but remember with the square root, that's like raising something to the 1/2 power. So you could write this as the limit as x approaches 2 from the right of g of x. Oh, excuse me. I'm going to do 2 times the limit of that times of g of x. And then all of this raised to the 1/2 power. So that way I can take the limit, multiply by 2, then I raise it to the 1/2 power. So you can write that 2 out front. So anytime you have a constant, you can write that out front. So as x approaches 2 on the right, so that's going to be here, which is going to go to positive 6 there. So this is 2 times 6 to the 1/2 power. which is the square root of 12, which can also be written as 2 square root of 3. Okay, you could leave it as a square root of 12 and a free response, but multiple choice, go ahead and convert it. All right, as 2 approaches, the limit as x approaches 2 from the right of f of x divided by g of x, remember, is the same thing as dividing those two out. So as x approaches 2 of f of x from the right, positive 2 is going to be a negative 2 here. So right there. So I have negative 2 divided by g of x from the right, which we just found over the one before, which is going to be 6, which gives us a negative 1/3. All right, and then lastly, we have f of x, the limit as x approaches negative 1 of f of x minus minus g of x. Remember, I'm just going to subtract those two limits. And then I'll go find those on the graph here. So as x approaches negative 1, we have, for f of x, I have negative 6. Yes, negative 6. And then minus what we get with g of x as x approaches negative 1. And you get negative 1 minus negative 1, which ends up being negative 5. Okay, so on those, if you'll notice, I did not write the limit, kind of write it all out, the first couple and then the last couple I did, because I want you to know that, like, for AP standards, you have to be able to write kind of so where you're thinking. You can't just say, hey, here's the answer and voila. So you have to be able to write these steps out and show them that you know the properties of when I take f of x, I can add that to, or when I take the limit of f of x, I can add that to the limit of g of x. It's approaching the same number. I can just add those two together and go from there. So you have to be able to write those two out, that step out, that you know those properties of calculus. So I really encourage you to be really conscientious of that when you're working these out on your own. And I'm going to be pretty stickler for that on quizzes and tests. And then that's it for the properties of limits. And we're fixing to get into some really fun limit stuff.